இப்போ ட்ரைபோல் வச்சுக்கோங்க ஒர்க் ஆகிடும்.
இப்போ ஸ்ட்ரீம் வரல யூடியூப்ல. ட்ரை பாருங்க. மணி எங்க போனாண்டா? வேர் இஸ் மணி?
ப்ரோ என் ஃபோனில் லைவ் கரெக்டாக
Good morning, dear students and research scholars. First of all, my congratulations for you all for your wish to present in this international conference. You have to follow few of the rules. Take 5 minutes to 6 minutes for your presentation. 2 minutes we will have the question session. So totally for each candidate 8 minutes, maximum 8 minutes. So this is the rule. So abide by the rule. If you have any PPTs, you can submit to this committee. They will be displayed. First participant, Karive. Have you submitted?
Yes. No.
Second one, Priyadarshi, you can ready for it.
ஒன்றும் இல்லைடா, இங்கே இந்த பாரு ஸ்ட்ரீமிங் போயிட்டு இருக்கு. ஒன்றும் இல்லை, இப்போ இன்கேஸ் ஏதாவது டைரக்ஷன் ஏதாவது மாற்றுறாங்க அப்படின்னா இதை மாற்றணும். ஓகேவா? ஸ்ட்ரீமிங் போயிட்டு இருக்கு யூடியூப். ஸோ அந்த டைரக்ஷன் மட்டும் மாற்றணும். வேறு எதுக்கும் உட்கார செஞ்சுக்கணும்.
இப்போதைக்கு இல்லை தான்.
இப்போதைக்கு உட்கார ப்ரெசன்டேஷன் பண்ணுறது அவங்க அந்த ஆங்கிள் போகும்போது அவங்கள ஆங்கிள் மாற்றணும். அவ்வளோதான். சரியா?
கீழேருந்து லைவ் ஸ்ட்ரீம் பண்ணுறாங்க. கீழேருந்து லைவ் ஸ்ட்ரீம் பண்ணுறாங்க. போனாட்டி வந்து
Good morning, everyone. Am I audible to everyone? Good morning, everyone. I'm Pradeep. I am studying 25 years of industry experience. I'm ready to practice in this case. Technology is a passion for me. So I'm doing a part-time history. This is history. Thanks for giving opportunity to the St. James Institute. Today I'm going to talk about shaping the future of healthcare towards the leading technologies, metaverse, and integrated. Can you move to the next slide? As part of this research topic, I already published a journal which focuses on this page. You can take a look. So this is the same line of technologies for use cases. It's a unique topic. So there, these are so why this today the guest speaker also take up the healthcare stuff. Why is that healthcare a major role in the technology? So first I'm going to discuss about the market size and how this the use case, potential use cases of the physical health and the mental health. And they have no service are discussing only biomedical level. But here they are going to discuss about the experience level, how it interfaces and how generating to the health. Can you move the next slide? See, I closely work with a lot of analytical companies. Every year in December they launch an analytical report. So last year before, this industry made a business almost more than $20 billion American dollars. By 2030, how much it's going to grow? That is more than $200 billion. And any business is making like 25% growth. This is very good. By year, it's going to make more than 40% growth. So that's a quick position. These are the primary use cases of healthcare. Any healthcare industry. So engineering is very simple. After 4 years, you get into the technology or get a place in the IT company. It's not the healthcare industry. Because healthcare industry, you won't get such like you won't get specimens, organs, pieces. The human body itself, you won't get that. That is why one person becoming an expert in the industry takes many years to do. So that is the reason this technology is going to help. So we can create a lot of simulated trainings for the medical industry. When I say medical industry, like the engineering, we have automobile, mechanical, that. Healthcare is a lot of areas of after they will do this bacteria virus comes to like the training also takes a lot of things. One person being an expert takes 10 years or something. The power of technology we can make the person get to the expert 5 years itself. Because the industry is moving, the world is needs and rehabilitation centers. But after a few certain years, people lost the hope and everything. By this technology, we can bring them the life back. And pain management nowadays, like early medicines, gives steroid medicines and all. There we can give this technology to the area. And telehealth medicines and remote health assistances, any aspect, right? So this technology is how it's going to see, even See, organ transplantation nowadays is very major surgical, pathological business. But by 2030, this is how the technology is going to be. Even patient assessment, organ assessment, even the hip rotations and all that nowadays, AR-based hip rotations. One person, major surgery and all that, simply scanning the X-ray report, you can give them what kind of material, the right treatment for them. That's what technology is. So that's how we can leverage the technologies until this all the pathology. This is currently it's not there, but the future of this is the technology for the care. Can you move this one? See, and another industries I would like to talk about that nursing industry. The whole industry now itself there is a huge demand for the nursing. When I say nursing, various areas is there. Oncology different product, gynecology different product, pediatrics different product, orthopedic different product. And every these things, one thing, the nurse come out of the nursing institute, they have only theoretical knowledge. They don't have practical experience. By the power of the XR, they can make a virtual hospital, virtual patient, various activities level we can make it. We can simulate as like the real hospital situations with the virtual world. And we can make that, same distractions what the nurses undergo in the real hospital, we can make it into the virtual hospital, by which people can get the knowledge. They want to get the knowledge, they can give the service to them. And one of the things, a lot of dropout happens in the nursing industry. By 2030, the nurse demand is like 50% is going to increase, but supply is very, very less. They are not coming for it because it's a very stressful job. But by this technology, we can make this people use for them. And yes, can you go to the next slide? Now coming to the mental health. See, a lot of the exposure therapies, a lot of people have skill development, support years and many these things. Psychotherapy, psychodramas are being conducted. One person to come out of this psychological problem, it takes many years to do it. Why? Because people have to take them to the real world situations and people have to learn and everything. There's a lot of risks there. But when you go for the power of the metaverse or the virtual reality kind of technologies, where all the problems can be made very easily, you can come out of problem. The technology can give a life to the people. Yeah, this is various psychodramas, psychopaths, psychoanalysis process is there. So where, manual process takes years. We go to the next slide. So now, that's all. Content creation plays a major role here. So the power of generating manual content creation is over major process actually. So the generating AI, create a content based on and put to the virtual environment, you can create a model. So that way, you can make use of your physical health solution very easy. The same, mental health solution easy. So that way, integrate AI Thank you.
இந்த ஃபிலிம் நான் பேசுகிறேன் சென்ட்ரல்
The flow of your explanation is very good. Also, the content what you have taken for your research is a very useful one. So what kind of methodology you are following?
Here, this kind of methodology is healthcare. We have to go for chosen qualitative and quantitative research. For clinical report, there is a framework, there is a report actually. You have to interview with the either doctor or nurses or the patient actually. Lot of questions exist and the calculation mechanism is there. The questions exist in mix of them possibly the negative questions are coming. You have vintage based on that only can be assessed on this time. So I am leveraging the same questions because the technology is evolving. Same questions can be assessed. So generating related questions also added and I take So at this time, all the technologies mentioned there, this generating AI, this mindfulness, it gives almost 70% mindfulness. And many people said that this kind of technology will reduce the drug addictions. And the power of generating AI technology, the reduction of the regulatory So right now, I completed the solution customer which is not available. Solution is itself you have to build it actually. I built the solution. So for generic wellness cases, almost 100% people are interested in that. So that's what the result I got. And the 4 years, the life skill development, right? Almost in targeting, so I have to work with the technologists and doctors, or life coaches, or counselors, right? Getting the medical records, the PID, check that progress in progress. But with my current status, the result is like
Since the data which you collect is very sensitive, you need to focus more on the data which is completely relevant on your solutions.
Exactly.
So
that's confidentially we maintain that. We won't reveal the name or the letter we collect, right? We won't collect the name or something. Just simply like the raw data of people who engage with gender, previous language and something. All these technologies are really helping with the traditional technology. So now I work with a lot of technologies as well. So that's how it's evolving.
thank you, sir. All the best.
Thanks. Thanks for the time.
Next one. Priyadarshi. Next to Rosh as a ready. Priyadarshi. Roshan is here. அதுக்கடுத்து பிரியங்கா. நீங்க வேணா அப்படியே இந்த ஆர்டர்ல ரெடியா இருக்கு.
Good morning everyone. I'm Roshan Sabina from the Department of Computer Science and Data Science. So today we're going to talk about the topic blockchain technology with data security about the smart systems. So let's get started. So why smart systems need better data security? So smart systems like IoT devices, e-government portals and banking systems will create a huge amount of data and that particular data is stored in a central place. So that creates a big problem. So there are 3 big problems which include cyber attacks, which is the data stored in a centralized place can easily get hacked. And the second one is the data tampering, in which the record can easily get changed without anyone's notice. And the third one is single point of failure. So the main system crashes, so everything else gets blanked out and it cannot be operated. So that's why blockchain offers a decentralized and tamper-resistant way to store and share the data efficiently. So what is a blockchain? So think of it as a shared notebook in which every computer has a copy of it, but no one can secretly rewrite it. In technical terms, we can call it as distributed ledger in which the data are stored in a separate block and that block is linked to the previous one. So if you want to change any one block, you have to change every single block on every single computer system, which is completely impossible. So that's why it creates an unbreakable chain of trust, so it is called as blockchain. So how blockchain keeps data trustworthy? So there are 3 things which keeps the data trustworthy. First one is the consensus mechanism, which lets the computer to agree on the valid data without any central authority. And the second one is the cryptographic security, where each block requires a digitalized fingerprinting and authentication for the IoT devices. So core ethical and security challenges. It also consists of certain challenges like data integration in which the record cannot be changed once everything is recorded, and the privacy concerns since the public ledgers are visible to everyone, and transparency so the people's identity can be easily get leaked. Why human judgment still matters? So it is because blockchain often called as trustless. Blockchain is often called as trustless because they only follow the rules and regulations, but they cannot judge patterns. Okay, blockchain is often Okay, so human judgment still matters because blockchain is usually considered as trustless and it only follows the rules and regulations. But it cannot judge fairness and it cannot even handle any unexpected situations. So that is why human oversight is still essential for the blockchain. So there are the real world case studies which include the supply chain tracking which helps to reduce the counterfeit goods, but the problem is it is costly to set up. And the second one is the healthcare record, which allows for secure sharing of patients' data, but the problem is it faces privacy regulation challenges, and the digital identity can reduce fraud, but it also raises legal accountability questions. So talking about the blockchain adoption around the world, there are different regions which uses the blockchain for different purposes. For example, if we take the developed countries, it uses the blockchain for the regulatory compliance, data security, and scalability. While talking about the developing countries like India, it uses it for IoT devices, e-government portals, and banking apps. And also talking about the social and economic impact, there are both the upside and downside on the society. So talking about the upside, it lowers the cost by cutting out all the middlemen and also speeds up and secure data exchange. And also it enables direct peer-to-peer transaction. While talking about the challenges, record keeping may disappear and people need to be upgraded on those skills, and also profit must be shared across the society. So to conclude, blockchain gives smart systems data security and to store and share the data, but the technology alone isn't enough. So the strong ethics, human oversights are more important. So if it used responsibly, it can become a foundational technology for the next generation.
What are all the other different applications you have went through for the blockchain?
I'm sorry, I'm not prepared.
Okay, regarding smart cities, smart homes, which is related to the whatever you have explained. According to that, in what different applications can this blockchain help?
It helps in the face identification systems and IoT devices that we use in our day-to-day life. And also for the bank system apps internally, we will use this blockchain.
Do you know about Bitcoins, Ethereum, all those?
No, ma'am, no.
Okay, also you said about the security.
Yes.
What are all the limitations you have encountered, and is there any solutions to overcome?
The limitation also
I'm asking you whatever you explained. Okay.
Prince. Prince. அது நோண்டாத வந்தால் சிஸ்டர் கொஞ்சம் இப்படி வந்துருங்க. இன்னும் கொஞ்சம் வந்துருங்க. போதும். ஓகே ஓகே.
Good morning to everyone. I am Priyanka from the Department of Computer Science from Valyama College Hall. Today my topic is ethical, social and security challenges of artificial intelligence. We all know AI has become an important part of our daily life, along with its benefits and the more challenges are there. Navigating the ethical landscape of AI. So in this presentation, we will ensure that critical ethical dimensions emerging from the rapid advancement of artificial intelligence. We will derive into the foundational and principal examine the most pressing challenges. AI is in dual nature. AI has begun an AI started as a research concept in the 1950s and has developed rapidly through machine learning, deep learning and generative AI. Today, AI is widely used in healthcare, education, finance and transportation and many other fields, and it causes the major challenges in algorithmic bias and fundamental job displacements and cyber security threats. The dark side of AI, it contains 6 major challenges, and they are algorithmic bias, privacy invasion, misinformation, job displacement, cyber security and autonomous weapons. Algorithmic bias and discrimination. There are root causes of bias, and bias in training data, it tells about AI learns patterns from historical data that encodes existing social inequalities and limited representations, proxy indicators and design bias. Algorithmic bias in critical application areas, there are 4 displacements are there, and criminal justice and employment, banking and finance and healthcare. In privacy invasion and surveillance, a massive data collection smartphones, it includes smartphones, social media and many other social platforms. And the second thing is surveillance capitalism. And personal data monetized for commerce gain and many other. In this misinformation and deepfakes, the generative AI includes the deepfakes and rapid spread, democratic information bulk. High-powered attacks, advertiser attacks, and dual user systems. Psychological and social impacts include the behavior manipulation, mental health, social tolerance, and skill erosion. In this behavioral manipulation, filters, database, and algorithms. Sorry. In this, AI can affect privacy, employment, mental well-being, and social relationships. Over-dependence on AI can also reduce our critical thinking and problem-solving cooperation. These are all the key challenges and solutions for AI governance, and they are bridging regulatory gaps, addressing job development, and fostering diverse development there, and strengthening the international cooperation. And there are also the disadvantages and broader risks for AI. So, in that, first thing is economic disruption. So, automation leads to job displacement and income inequality, impacting labor markets globally and necessarily workspace training. And second thing is skill degradation, and third is environmental impact, and lastly the systematic prevention. So lastly, the conclusion is responsible AI development, and addressing the complex ethical, social, and security challenges of artificial intelligence includes the acknowledgement key challenges, strengthen governance, and develop the ethical framework, and foster collaboration, and path towards a sustainable AI. And lastly, I conclude my presentation with AI is powerful, but responsibility must be worked on. Thank you. I appreciate your effort, but when you are presenting for any conference, you have to come with any problem, any specific problem which is related to social relevance problems. It is like just you are explaining what are all the ethical issues in AI, and you are talking about diverse areas. It should be like, the conclusion should be like, at least these are all the limitations or drawbacks we have, and what might be the solution. At least that you can say. Sorry for the inconvenience. This is my first thing, so I get that. So this is just a suggestion, but I am appreciating you for your effort, for your volunteering to present in the conference. But from the next time, you identify any specific problems, like from healthcare or from any different domains you can take. What kind of problem you are focusing, what are all the methodologies already in existing researches they have done, and in which way you can utilize those. In that way you can. Okay.
Good afternoon, everyone. I am Kirtana from the Department of Computer Science with Data Science from Valiyaman College, Proviman. Today I am going to present on topic Federated Explainable AI for Privacy Preserving and Healthcare Protection. So first let us look at the problem statement. Healthcare data is very sensitive, so sharing patients' information to various hospitals which creates privacy risk. And also AI models do not clearly explain why those predictions are made. So these kind of challenges we have for healthcare AI models. Moving to the next slide, propose the solution. Here we use federated learning. The federated averaging methods are used, like only sharing the updates of those models in local hospitals to the global server. We will explain it in the architecture in a moment. Like first a global model is created and then these models are sent to various hospitals. Those hospitals use their local data and train the model. Only those updated models are sent back to the global server. Using that federating averaging method, those predictions are made with explanations for doctors to understand. Then moving to the next slide, privacy risks and mitigation. Even if the patient data are inside the hospital, there are still some privacy risks. Like we use differential privacy, which adds small amount of noise to the data set, so suspicious model updates can be removed instantly. Then advanced privacy threats. There are also kinds of advanced privacy threats like model poisoning and so on. So to reduce that, we are using encrypted communication and aggregation. And also those suspicious models are identified before sending it to global server. Then local training. Here I am going to explain about the local training done by each hospital before sending it to the global server. First, each hospital clears and cleans its data for the analysis. Then it is trained using its local data. After using that, all these data are suspicious updates in that are removed using aggregation and encrypted communication. And also, we are adding small amount of noise to avoid attackers to identify the individual patient data's information. These are the steps used by each hospital for local training. Then experimental setup. In this, I'm going to explain the full concept. Like from the beginning, each hospitals are given to the global server. Then each hospital, as I said, it will train using its local data. Then all these data are individually sent to the global server created by the main data. Then all these are undergone the federated averaging method. These includes accuracy, precision, recall, access score and all these. And mainly sharp method is used for, it will explain which feature gave more importance to further prediction. It will make doctors to understand why those predictions are made. So sharp plays an important role in this method. Then moving to key results. So in the key results, I'm going to say that instead of using central traditional models other than this, using federated model, at the same time the data are safe and also same accuracy prediction was made with the explanation for the doctor's model. Then moving to limitations. Next. So here the limitations are I have done using small data set and also the sharp computations are right, but it has only small kind of not to the more complex computations. And also these are the areas I need to improve in the future work. Then moving to the next slide. In the future work, I would say that everyone can use federated learning method instead of traditional models for a safe and explainable models in healthcare domains. And also it can be connected to electronic health records or simple dashboards for practical real-world prediction usage in healthcare. To conclude, I want to say that federated learning model methods works closely with hospitals to provide more understandable and accurate prediction, saving all the patient efforts. Thank you.
Yes, very nice presentation. Have you published this paper?
Yes, ma'am. No, not yet, ma'am.
Since you have written as author, Kirtana,
Yes,
you have mentioned your name as author for this. Is the paper ready?
yes, ma'am.
Okay, it's a good attempt what you have taken. You have included explainable AI in generated learning.
Yes.
Why you have chosen a sharp instead of lively?
I think SHAP mostly works. Mostly, if there is a disease is spreading, we have to identify. Mostly, we want to know the symptoms. Which symptom was more important for the disease, or like which is related to the disease. So, SHAP works like it gives more importance to the feature. So, doctor can easily identify if some person is like having this feature, high needs, this is made. Except for SHAP important features.
Okay. For the pre-processing, have you used any specific algorithms or any specific techniques?
Not that kind of specific one, just like cleaning and preparing the data.
Where will you get the data?
I have done this paper with my, we both done it, teamwork, ma'am, like she done out of that. We know the process, but I don't know the in-depth process.
What kind of accuracy can we expect for this privacy preserving?
Till now, it's like all the patient data, individual data are privacy using federated. If we use like traditional, it will be another privacy. It will be exposed if attackers use that. Federated learning allows us to only updates are we are sending to the global server, so the data are still inside the hospital. Even inside the hospital, we are using methods to remove the suspicious model, and also we are adding some kind of noise like unidentified records to make it more secure.
Very good for your understanding.
Thank you. Good morning, everyone. My name is Akshita. We are from Civil Voice. We are here to present talk from puzzle logic decision making. Usually, we use our AI for decision making, problem solving, and for learning. So we use puzzle logic for making decisions even more clear for people. Usually AI doesn't give, mostly AI gives two options like true or false. By using this fuzzy logic, we can give midline, like there will be a different levels of truth. So using this fuzzy logic, we can give the different levels of truth. For example, we can take temperature. If it's 30 degrees outside, we can say high, medium temperature. It is not high. 40. If the temperature is 40 degrees, instead of representing in a numerical value, it converts it into a variable and makes it clear decision and makes it a sense and understandable manner. Next here. See, the temperature is low, medium, and high. If the temperature is 40 degrees, we can mention it as a high. If the temperature is 30 degrees, we can mention it as a 20 degree like medium. If the temperature drops 20 degrees, we can mention it as a low. So by using the binary numerical values, we can't mention zero in true or false. We can't mention this like true or false. So we can mention it in a high, low, and medium. So using fuzzy logic, it gives explainable decisions that we can easily understand. applied rules. And the number of rules can rapidly, if the number of rules grows, the input also increases, the output also increases. So, to attain this, here the fuzzy logic intelligence is used. First point, the role of the fuzzy logic. Here the fuzzy logic helps in making an intelligent decision, and the fuzzy logic handles an uncertainty situation into an understandable answer. Next, applications of fuzzy based intelligence. We can apply. We can take a real world example, the washing machine. It has a high, low, and medium temperature. Here, we have used the fuzzy logic. And advantages. The advantages of fuzzy logic is simply we can say it as understandable. It is understandable for all, and some limitations. What the limitation means? The rules should be set up by manually. It cannot automatically set the rules. And the future opportunities. Nowadays, modern AI is using. We have applied fuzzy logic in modern AI. So, future opportunities. I think it has higher opportunities now. Here they have given the history of the fuzzy logic. First, N.S. Raja was introduced fuzzy logic in 1965, but it follows the old traditional fuzzy logic method. Next, Mamdani in 1974. She made the traditional fuzzy logic into automation fuzzy logic, like it can understand. And next, from 1990 to 1993, the fuzzy logic grew even more better, like using modern AI. And now we use machine learning, deep learning. In such fields, fuzzy logic has been applied. Now it has developed rapidly. The following slides they explain better.
This is the methodology of fuzzy logic. First we define a problem and then classification, which is
Okay, no problem due to time. You are not able to explain, but you can answer. Please, we can check your understanding level. She said hybrid approaches of fuzzy logic will help to reduce many problems. What kind of hybrid approaches you have went through?
For example, washing machine, it uses water and the spill. The water is high, the spill level will be minimum. Coming fuzzy logic, it measures the water level and adjusts the speed that the water according to this level. Like that, used in washing machine. Fast also is used as the auto braking system. When bar is unstoppable or in use that it travels in high speed, it automatically brakes the car and warns the user.
Okay, you explained about the logic of fuzzy logic, but you should be clear on what are all the hybrid approaches which can take the solution for the risk. We can go through it later. And one more thing is how this fuzzy logic in future, how it will incorporate with the AI-driven systems.
Already it uses AI to understand human. It translates numerical to human language. Already converts in uncertain things like already used as a mostly comes for little academic changes, like 10 to 20. Conversion diagnostic workflows occurs from earlier impaired observers. And then proposed AI planning. A novel hybrid AI framework combining work-based feature extraction with the peak action. Delivers global spatial concept comparison along segment. Clinical context and needs. 5 years survival strategy. Survival rates remains capped at approximately 60%, stressing the urgent need for earlier and accurate attention. Regional development. Features range from purely active to certification with complex pedestrian results and reaction and partial distraction. CNN limitation. Standard CNN excel at the local textures analysis but struggle with long range structural dependence. Clinical efficiency. Pilot deployment demonstrate 15 to 20% reduction in overall diagnostic turnaround time. Birth feature extraction. Image patch tokenization. Radar scans are quantitatively divided into uniform patches, 16 to 16 patches. Then each patch is mapped to high dimensional embedded space, treating data images as a sequence tokens. Then bidirectional self-attention. Employ multi-layer bidirectional self-attention to learn biologics spatial impedances across entire modes. Detaching and partial degradation. Compact binary compression. Extract continuous high-dimensional word vectors and compress them into ultra-compact binary hash codes. Semantic reversion. Supervised hashing ensures radar digital scans with similar catalogs. Sublinear search. Individual directory keys and hash tables for heterogeneous historical case matching. Pipeline analysis. First introducing, then bird future map, then deep hashing, clinical output. Core methodological innovation. Transfer learning, then end-to-end learning, scalable lookup. In transfer learning, modern pre-training. Then end-to-end training integrates cross-entropy loss for diagnostic classification. Scalable lookup reduces memory footprints by 90% plus compared to storing the raw dose future purpose in PSPS system. Radar workstation. Real-time second opinion.